We've already learned how to find components from a vector when we're given the magnitude and direction of the vector. In this video, one of the things we're going to talk about is to go do the opposite. So how to find the magnitude and direction of a vector if we're given the components. The first thing we're going to do is to start by drawing those components tip to tail, which means the tip of one component, the tip of one vector, touches the tail of another. So one example would look something like this if I had a vector pointed to the right and a vector pointed downward. Now the order in which we draw these doesn't matter, so I could draw my downward arrow and then my arrow going to the right, and we'll get the exact same result. The next thing would be to draw that resultant vector, or kind of the overall vector that's made up of these components, and we always go from the unpaired tail to the unpaired tip. So on my diagram on the left, that would look something like this. So I start with that tail that's all by itself, and I go to the tip that's all by itself. And on the diagram on the right, it looks like that. You'll notice that even though these triangles look different, those blue arrows look the exact same, showing that it doesn't matter exactly what order we draw our component vectors in. Then to be able to find the magnitude and direction of that blue vector, that resultant vector, we're going to use the Pythagorean theorem, and we'll use some trig functions to find its magnitude and its direction. Pythagorean theorem, of course, works because the x and y components are at a right angle to each other. And when we say trig functions, we're typically using the inverse tangent function to find an angle in there. One thing that's really important to note is that when we say we're finding the direction, it's going to include an angle, but it's also going to depend on where that angle is measured from. So for example, sometimes you'll see that angle given as it would be on the unit circle. So the blue vector that you see on this screen right here might be given at an angle of 330 degrees, or perhaps negative 30 degrees. You may also see it written as 30 degrees below the horizontal, or we could go the other way around. So we could say instead of 30 degrees, 60 degrees to the right of the vertical, depending on exactly which angle we're giving. So we'll see lots of examples of those. Another skill that we need to have for vectors is adding vectors. And this kind of is putting together all the things that we have learned so far about vectors. So our first step in adding two or more vectors is to find the x and y components of each vector. Then we're going to add the x components to each other and add the y components to each other. When we're adding those components, of course, we're paying attention to the direction. So if one of our x components is pointed toward the left, we want to make sure that that's a negative component. So when we say that we're adding them, if there's a component to the right and a component to the left, really what we'd end up doing is subtracting those magnitudes. Then we'll have a total x component and a total y component, and we're going to use that skill that we just talked about to find the magnitude and direction of the resultant. So let's look at an example of doing exactly that. Excuse me. I have two forces here acting on an object, and we're given the magnitude of those two forces, and you can see the direction there. And our goal is going to be to follow along those steps. And so for starters, we're going to start by finding the x and y components of each vector. So starting with F1, to find those components, again, we're going to draw the overall vector, and then we'll draw its components in here. So that's what its x component looks like. And I'm going to draw its y component, making that triangle right off the bat, kind of like I showed you in that last video. And we see that the angle between these two vectors is 120 degrees, like it's marked right there. But this angle in my diagram would only be 30 degrees. And so if I want to find the x component, I'll call this F1x, and the y component, F1y. I want to use those trig functions. So if I use the sine function, the sine of that angle 30 degrees is opposite over hypotenuse. So I would get F1y divided by that hypotenuse, which is the magnitude of that vector, or 215 newtons. Making sure your calculator is in degree mode is really important here. to get an accurate answer. And you'll find that the y component of this vector is downward, so negative 107.5 newtons. Similarly, we'll use the cosine function in order to find the x component, since cosine gives us adjacent over hypotenuse. And when we solve for that x component, we end up getting a positive, since it's pointed to the right, 186.2 newtons. Now the nice thing is F2 is pointed directly upward, so finding its components is significantly easier. The x component is 0 since it's pointed directly upward, and that y component is equal to the total magnitude of that vector, which is a positive 240 newtons, positive because it is pointed upward. So that's step 1, finding the components of each vector. And then in step 2, we're going to add together like components to find an overall x component and an overall y component. Since only one of these two vectors had an x component, the overall x component of my resultant is just the x component of F1, which we said was 186.2 newtons. And for that y component, I'm going to add together F2 and that y component of F1. So 240 newtons plus a negative 107.5 newtons ends up giving me a positive 132.5 newtons. My last step, step 3, is to take those two vectors that we just came up with and to find the resultant. And we learned that in order to do that, we're going to start by drawing those vectors. And so I had a positive 132 that was the y component. For my x component, I had a positive 100 and, I keep getting this wrong. Third time's a charm. I had a positive 186.2 Newton x component. And I had a positive y component of 132.5 newtons. And so when I draw those two tip to tail like I've done here, I see that my resultant looks like that. Again, going from the unpaired tail to the unpaired tip. I can use the Pythagorean theorem to find the magnitude of that resultant. So a squared plus b squared equals c squared. I end up getting 228.5 newtons as its magnitude. And I'm going to go ahead and find this angle right here, since that is my angle within my triangle. And in doing that, I'm going to use the inverse tangent. And when we're doing inverse tangent, we're doing opposite over adjacent. So 132.5 newtons divided by 186.2 newtons. And when I do that, I find that my angle is 35.4 degrees. And I'm going to list that as being above the horizontal. You can also say that it's above the positive x-axis, which I actually prefer to above the horizontal, since above the horizontal could technically be in the first or second quadrants, and this specifies that it's definitely in the first quadrant. We'll of course do lots of practice with this and apply this to the content that we are learning. As you see here, we're adding forces together, but there'll be several other times in class where we will need to add together vectors.